Yo, what's up guys? Today I'm showing you how I do my inventory systems in my Roblox games. A lot of people ask me how I do them, and I never have given a clear answer. So here it is. This isn't the right way. This isn't the best way. This might not work for your scenario. Um, but this is pretty much how I do it in all my games, and it works for me. I like how it is, and yeah. So without further ado, we have a brand new place file, and I'm gonna actually just code everything for you. I'm gonna do the type definitions. I'm gonna do everything. So, yeah. First, we're gonna make a module script, and I'm gonna put it in server storage. Um, you don't have to put it here. I'm just gonna hit player. And when I use this module, I use it as a replacement for the player instance. I sort of look at it as like a player plus because it's just the player instance with extra data on it, which is your save data or your inventory. So I'm going to use strict here, and I'm just going to say player implementation, new, pass in the player, and just return nothing. And then we'll say get, which is the player, which will return a player struct, maybe, and then remove. And this will just do a basic removal. Uh, so with this type, we also have to make the player struct. I know if you don't really code often, or if you have coded, you haven't really touched types, this means nothing to you. Give it a second. Give it a second, and it'll all make sense. First, we'll use the type, the player implementation type, to define our module. So we'll say player, and we'll cast this table to be the player implementation, which now allows us to say function player.new and pass in our player, function player.get, which passes in the player, and a function player.remove the player. For the player struct, we'll just say, I don't know, or the constructor will say, we'll define our player struct, which has the player inside of it. We can say our data, which is this. We'll put type player data here. Then we'll have our inventory. The inventory is how I do it is a little bizarre to people, and the only reason why I do it this way is because it's really, really easy for me to understand. It's really easy for me to add in attributes to items, and you also don't have to worry about indexing. So let me just show you. We're just going to call this inventory element. So inside of here, we'll define another type called inventory element, and that is the ID, which is the item ID, and then the amount, which is a number, and that's the amount that you own. So an example player data might look like this. This is an example player data. Your inventory will be right here, and then you'll have ID equals 1, amount equals 50. This means that you own 50 of the item that is represented with the ID 1. And then you can do 2, you can do 3, you could do it in any order, 3, 2, and if you've coded it correctly, you will never ever have a duplicate ID in your inventory. If you do, then you've coded something wrong. So this is why the system doesn't. This is why the system works, because if you've coded it correctly, you will never ever have a duplicate ID. And the inventory, you don't have to worry about broken indices where you say, hypothetically, if you want to use the ID as the index, if you said 1 equals 50 and then 3 equals 50, then serializing it or like converting it into a string and then back to a table would screw up the keys, because the keys would then become strings, and you don't want that. Um, and that's how I used to do my inventory. But then I was like, there's definitely a better option. So this is how I do it. And uh, now you might be curious. Okay, hold up. Um, Now that you have this, how do you get the item with the ID? It's really easy. I usually create a folder called collection in replicated storage, and then I create my items, which is like this. And then I'll say type item, and I'll say name equals, I don't know, or name is a string, and then description is a string, and then you can add in a bunch of other attributes. It isn't limited to this. And then you can return. If I want to say like name is the Fosh's crown, I don't know, and description is this, I could cast this to an array of items, and now, because it's an array, technically, this is the first element, which also means that it's the first ID. And so we can add in a bunch of things super quickly. The Fosh's, I don't know, shield, the Fosh's shirt, I don't know. And so now item 1 is Fosh's crown, item 2 is Fosh's shield, and item 3 is Fosh's shirt. And we haven't done anything crazy. And so that's how I typically represent player data. And how you would access it is you would create the data. Let's do player, or private variables is players, and we'll say the key is the player instance, and then we'll say player struct, player equals player struct, and then we'll say data, player data. This should highlight because our data isn't correct. Yep. We'll say inventory is this. And now we have our inventory and our data. So if we want to say, if we want to get our player, we could say if player is descendant of players is false, then return. Otherwise, we'll return players player, because you don't want to access their data if they've left. It's stupid too. It's stupid too, and there's like a bunch of reasons why, but just simply it's bad practice to access a player's data unless you really mean to. But like if I was adding it into a player's data after they've left the game, there's a bunch of other scenarios where like that could be a problem, like duping or whatever. But I don't know. That's, you don't really care about that. You don't care about that. You're not asking for that. My input on that. And so yeah, we have get, and then we'll say local player struct equals players player. We don't use get here because the player's leaving. If player struct is nil, then return end. We'll say players player equals nil, and then we can do to do save data. I don't know, whatever you want to do here. And you can return player, and by returning this module, you can now get the player's data wherever you want by just requiring this module. And you say player.get player. It'll return this if the player exists, if the player's data has been loaded, and they're a descendant of players, and you can do stuff with it. Yeah, I think that's it. I mean, obviously I can show like function player has item ID. So we'll add that method here. Player ID number, and then we can do Boolean number. Boolean is yes or no, and number will be the index in the inventory, because the ID is not the index in a player's inventory. And we talked about that because the serializing and all that stuff sort of screws up. So we can say local player struct equals player.get. Remember, you want to use get anywhere that isn't remove, because remove is removing it. Pass in player. If player struct is nil, then return -1 or false -1. And then we'll say v in player struct.data.inventory do if v.id equals id, then return true idx, which is the index. Otherwise, return false -1. So that's has item. We can do function player.add item to inventory, player ID amount. We'll just copy this, paste this here, remove item from inventory, player number. You can make this return a boolean, whether it's successful or not. I think I do that sometimes I don't, just based on what my use case is. Okay. So we have all this. We can say, grab this again. If the player struct doesn't exist, we'll say local has item idx equals player.has item player ID. If has item, then else. We'll say player struct.data.inventory idx.amount plus equals amount. Otherwise, we'll say table.insert player struct.data.inventory ID equals ID, amount equals amount. So remember, this follows the same structure as our inventory element, because all of our inventory elements are just this. So we'll add the ID and the amount there. And then function player.remove item from inventory, player ID amount. Did the exact same thing here. However, we're only going to do something if has item. If has item and this amount is greater than or equal to amount. So then we'll say this. And then if this amount is equal to 0, then table.remove this. I know there's probably a million ways to do this faster or more optimally or whatever. Suck my balls, bro. You dude. Any sort of optimization here is, I mean, easy to find. Like you could cache this. You could not subtract if the amount's going to be 0, and you know all that. But like at the end of the day, bro, I mean, if it works, it works. And also, if this ends up being the bottleneck of your code, you're doing something wrong. So yeah, we could test this as well, just to show. Local player, or we're gonna say require local server storage. Game get service server storage require player dot or server storage dot player. Local player is this, and then we'll say local data. We'll do local players, game get service players, players dot player add connect function player, test dot wait like 0.2. I don't know it. The only reason why I'm waiting is so the data is guaranteed to have been made. So we'll say player struct equals player.get player. if player struct, then print player struct dot data. Really? Did I not local function player added player? Player in players get players do player added player. Okay. Dude, what the fudge is happening right now? Oh, duh. I'm not initializing the players. So what you just say set up players.player add connect player dot new for player in players get players do task.spawn player.new player. The reason why I use task.spawn here is because this yields. So eventually you're going to do load save data here. And if you have all the players waiting in line for the first player's data to load, and there might be some like taking some time to load one of the players, whatever, you want them all to load pretty much at the same time. That's why you'll say task.spawn. And then players.player removing connect player.remove. Cool. And so now we're printing our player struct, and we print our data. And then we can do things like player.add item to inventory, player 150. And if we print our inventory, now we have 50 of the first item. And to test that removal is working, we can say remove 51. And then we'll say remove 50 because our data, or how we code it, you can only remove the exact amount that you have. So it didn't remove it because it's still here, and then it should have removed now. Yeah. Cool. Yeah, so that's it. That's how I do my inventory. Super easy to fire back and forth to the server or the client. All you have to do is just if you really want to minimize bandwidth, just fire this. You can fire this. And it's a little bit weird with this one, but you could just say like local element is this, and then you fire element, and that'll update on the client. And then with here, it's super easy. You can just say idx equals player struct.data inventory plus 1, or we don't need to say plus 1. We can just put right below here. And then you just fire player struct.data.inventory idx. Simple as that. IDX will always be the target, and that'll be it. And then on load, obviously, you'll just fire the entire inventory. So yeah, that's how I handled players and player data in general. If you have any questions, let me know. And for all the fucking idiots in the comment saying, you know, you don't have to say equals equals nil, or you don't have to say equals equals false, whatever. Dude, suck my balls. A, it doesn't matter. B, dude, it's just easy for me to read. Actually, here probably doesn't make that much sense. I could just say not, if not descent of players. But dude, shut up. I'm doing equals equals false just to fucking spite you. All right. I'm getting off. Later, guys.